Hello guys, how are you today? So today I'll be explaining the topic 5 organic chemistry, but only the CQDs, only the questions. So let us go down and try to look for some questions. I think we have our first question over here, which is CQD number 4 grid. What are hydrocarbons? Which of the following are classified as hydrocarbons? So hydrocarbons, they are organic compounds containing only carbon and hydrogen. Okay, so again, hydrocarbons, they are organic compounds containing only carbon and hydrogen. So when we are looking at things classified as hydrocarbons, they should only have carbon and hydrogen. So for sure, A is an option. B will not be an option because it has oxygen. Also, C is not an option, so D is also an option. So the two answers that are classified as hydrocarbons, they are A and D. So now we'll move on to the next CQD, which is CQD number 1. In part A, they said, define the term homologous series. So for part A, I'm going to write it over here. A homologous series, okay, it is a family of related compounds that have the same functional group. So again, a homologous series is a family of related compounds that have the same functional group. An example is probably alkanes, alkenes, alkynes. Okay, so that's CQD number 1A done. Alright, so we finished part A, we move on to part B. List 3 general properties of members in the same homologous series. So of course, if they're from the same homologous series, from the same family, they will have similar properties. These similar properties, we have actually a lot of similar properties. You can see them up here. These are the similar properties. However, since they stated list 3 general properties, you can choose any of these 3 and you could put them. What they put in the answer key is that all members of the same homologous series have the same general molecular formula, so same general molecular formula, okay? The second answer they put is that all members of the same homologous series show similar chemical reactions, okay, that may vary in vigor and rate. And then the final one, they put that similar methods of preparation. So they will have similar methods of preparation. So that is it for CQD number 1. Let us move on to the next CQD, which is CQD number 5 grid. In CQD number 5 grid, they said give the general molecular formula for alkanes. As you know, you can look up, or you have to memorize it, by the way, the general molecular formula for alkanes. It is CnH2n plus 2. Now they said give the molecular formula of an alkane having 3 carbons. If it has 3 carbons, it is going to be C3. You're going to substitute N with 3. H2 times 3 plus 2. So then it becomes C3H8. So very simply, C3H8 is the molecular formula for an alkane having 3 carbons. Now we will go down to the next CQD. We have CQD number 7. Okay, so this one I will need some space for it. Hexane, C6H14, has 5 structural isomers. Draw the condensed structural formulas for isomers of hexane and give the name for each. Okay, so I'm gonna do each one by itself. First of all, hexane. You don't have to memorize what it looks like. I'm going to get it from the answer key. It looks like this. CH3, single bond CH2, single bond CH2, single bond CH2, single bond CH3. And what did we discuss before? This is first of all hexane. We discussed that when we are dealing with isomers, we can never put the branches on the terminals. So you have to leave the CH3s alone. You never put branches on the terminals. However, you can only put the branches over here. Okay? So this is hexane, first of all. A structural isomer of hexane would be like this: CH3, single bond CH, okay? Then it's bonded to another CH3 over here, then single bond CH2, single bond CH2, single bond CH3. So let us check all the conditions. It's supposed to have 6 carbons. It has 1, 2, 3, 4, 5, 6. So we are good. Now let us try to name it. First of all, we are gonna look. In the branch, it is on which part of the carbons, which number of carbons. So before we name that, we have to number the carbons. We're gonna start that. Okay, the branch, it's closer to this side. So this side, it is 1. So 1, 2, 3, 4, and 5. Okay? So by naming it, we start that. It is on carbon number 2. And now the branch, what is the formula of the branch? The formula of the branch, it's CH3. So how many carbons does it have? It has 1 carbon, so we are gonna name it methyl. Okay? Now we will go back to what? We will go back to the skeleton or the base, and we're gonna count how many carbons we have. We have 5 carbons. So then we're gonna put it as pent. So pent means 5 and then ane. So the name of this compound is 2-methylpentane. So now what happens if we did the structural isomer like this? CH3, single bond CH2, single bond CH, single bond CH3, single bond CH2, single bond CH3. Again, this branch, it's close equally on both sides. So if you name it like this, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, it will not matter because it will still be on number 3. So when we first start naming it, we are going to put which carbon it is located on. It's located on carbon number 3. Now, the branch, it has only 1 carbon, so we will call this methyl. And we will go now to the skeleton. It has 1, 2, 3, 4, 5 carbons, so this is also pentane. Okay, another structural isomer of hexane, it is CH3, single bond C, CH3, CH3, CH2, CH3. Okay, now this one is gonna be a little bit difficult, but it's also gonna be easy. So look at the 2 branches. As you can see, they are closer to this one. So this is gonna be the first carbon, second carbon, third carbon, and fourth carbon. So again, we start that the branches, they are located on carbon number 2. But because there is 2 branches, you're gonna say, okay, this is on number 2 and this is also on number 2. So it's gonna be 2, 2. And then we will put a dash. I think there's also no need for a dash. But because we're dealing with 2 branches, okay, and they are both the same, they are both methyl, we are gonna say dimethyl. Okay? And then finally, we will go to the skeleton and we're gonna count how many carbons. We have 1, 2, 3, 4 carbons. So then it's gonna be butane. So now another structural isomer, which I think is the final structural isomer, it is CH3, single bond CH, CH3, single bond CH, CH3, single bond CH3. Okay, so again, we're gonna count based on which one is closer. So you can take this one to be closer or this one to be closer. Either way, it's gonna be the same. So if I started with this one to be the first carbon, second carbon, third carbon, and fourth carbon. And now we have to name them. We have to first of all put on which carbons they are located. They are located on the second carbon and on the third carbon. Okay, and now because they're both the same, they are both methyl, we are gonna write dimethyl. And now we count the number of carbons in the skeleton. So 1, 2, 3, 4 carbons. Then it's gonna be butane. That is it for CQD number 7. Let us move on to the next. It's CQD number 2. I think they already gave us the answer, but let us just forget about the answer. Let's forget that this exists. So let us forget that this exists, okay? And we have to write an equation to represent the complete combustion of C3H8. Again, it is C3H8. Complete combustion means it will react with oxygen to produce carbon dioxide in addition to water. As you can see, they are not balanced. So to balance it, you're going to put an 8 over here, a 6 over here, a 10 over here, and a 2 over here. That is pretty much it. We move on to the next question, which is, was there a question up? No. Let us go down to see the next question, which is CQD number 8 grid. In CQD number 8 grid, they said methane, CH4, undergoes a substitution reaction with chlorine, Cl2. What's the factor that speeds up this reaction? It is either UV light or sunlight. So whenever you see substitution reaction and they ask you for the factor that speeds it up, it is UV light or sunlight. Now they said, give the chemical equation for the substitution reaction between a methane molecule and a chlorine molecule. So methane, CH4, will react with the chlorine to produce, by substitution reaction, one hydrogen will go here, one chlorine will go here. So it becomes CH3Cl plus HCl. That's pretty much it. We'll move on to CQD number 6 grid. So here they told us, give the general formula for alkenes. So alkenes, their general molecular formula, it is CnH2n. Now, a molecular formula for an alkene having 2 carbons, it's going to be very simply C2H4. And now we go to CQD number 10. Classify the following into saturated and unsaturated hydrocarbons. Okay, so what you should know over here is that saturated, it only applies to alkanes, whereas unsaturated, it will apply to the alkenes and any other group. Okay, whereas saturated only belongs to the alkanes. So you can do this in many ways. You can follow the molecular formula of alkanes, which is CnH2n plus 2. So let's try it. Okay. First of all, let us find saturated ones. CnH2n plus 2, it's going to be, first of all, hexane. Then this one over here. Then methylpropane. Oh, but here we reached something difficult. Cyclopentane. Now, if you look at the molecular formula, it will give you the molecular formula of what? Of an unsaturated alkene. But if you read the name, it is cyclopentane. It ends with A-N-E, so it is actually an alkane. So cyclopentane, it ends with ane, so it is an alkane. So for sure, it's going to be saturated. So do not only focus on the general formula, but also on the naming. If it ends with the ane, then it's an alkane. If it ends with ene, then it is an alkene. And that leaves us with unsaturated being only heptene. So that's pretty much it for CQD number 10. We'll find the next question. So, no question here. Actually, wait, did I miss any questions up? No questions missed. We come to CQD number 3. It is a long question, but I hope it's not gonna be long while writing. Okay. Is the ethene molecule planar or 3-dimensional? Here you just need to know that it is planar. I do not believe they're gonna ask us because we did not take this specific part. Okay. Write an equation to show how ethene is produced from ethanol. Ignore state symbols in your equation. What conditions are needed for this reaction to occur? So, the equation of how ethene is produced from ethanol. First of all, ethanol, it is C2H5OH. It will decompose into ethene, which is C2H4, and water, H2O. Okay, so for the conditions, okay, we need to heat it. So, heat it with excess sulfuric acid, which is H2SO4, at about 180 degrees. Now we move on to part C. In part C, write an equation for the complete combustion of C3H6. Ignore its state symbols. Explain why the flame is colored unlike that of C3H8. So C3H6 plus oxygen will give us carbon dioxide plus water. So if we want to balance it, we're going to put a 6 over here, a 6 over here, a 9 over here, and a 2 over here. Now, why is the flame colored unlike the C3H6? This is due to carbon. The carbon will cause a smoky color in flame. Okay, so that is pretty much it for part C. Now we move on to part D. Write equations showing what happens when C2H4 reacts separately with hydrogen and hydrogen chloride. Ignore state symbols in your equation. Give the name of the product in each case. What name is given to this type of reaction and why? So C2H4 reacts with hydrogen by itself. Okay, it will undergo addition and it will produce C2H6. And then C2H4 plus hydrogen chloride, HCl, will undergo addition and produce C2H5Cl. Now, because these are addition reactions, they will produce something new product. So this over here, it's called ethane, and this over here, it is called chloroethane. That's part D done. Now we move on to part E. How can you distinguish between ethane, C2H6, and ethene, C2H4? Write the equation for any possible reactions. You could get bromine. You could do a bromine reaction because we know that ethene will decolorize bromine because it will make a new compound, whereas ethane will not decolorize bromine. It will keep it brown. So C2H4 plus Br2 in the presence of CCl4 will give us CH2Br-CH2Br, whereas C2H6 plus Br2 in the presence of CCl4 will give us no reaction. That is pretty much it for CQD number 3. We now move on to CQD number 9. Give the structural formula for the product of each of the following chemical reactions. So, for part A, it is what? It is ethene will react with H2O gas. So because ethene, it is an alkene, it will undergo an addition reaction. So it is gonna be, like, the double bond is gonna break, and then it is gonna give us C, single bond, C, H, 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 H. Over here we have an H, and over here we have an OH. And this is very simply how the addition reaction works. When it is with Br2, it will break the double bond, and it will be C, single bond, C, H, 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 and over here you have Br, and over here you have Br. And then finally, H2, you will break the double bond like this, and you will get C, 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 so like it's all single bonds now. And then we have H over here, H over here, H over here. Now here this gets a single bond, this gets another bond, and this gets a bond here, and a bond here. So very simply, this is it. Let us find the next question, which is CQD number 12 grid. In CQD number 12 grid, they said give the general molecular formula for alkanols, which is alcohols. It is very simply CN, H2N, plus 1 OH. Part B, give the molecular formula of an alcohol having 2 carbons, so it's gonna be C2H5OH. That's very simply it for CQD number 12 grid. We will move down to CQD number 13 grid. Ethanol can be prepared biologically from glucose. Part A. Name the biological process of preparation of ethanol from glucose. This is called fermentation, or more specifically, alcoholic fermentation. Give the chemical equation for this process. It is glucose, C6H12O6, in the presence of yeast with no oxygen. It will form 2 ethanol, so 2C2H, what did I write? 2C2H5OH plus 2CO2. For part C, what are the conditions needed for this reaction to occur? We need the absence of air, okay? As I said before, so no oxygen, and yeast. So you need yeast, but you do not need air, you do not need oxygen. Now finally, suggest a technique to separate ethanol from its final solution. Usually we will use fractional distillation. Okay, we'll move on to the next question, which is CQD number 11. So in CQD number 11, they said, give another name for methanol and ethanol. So you could say that methanol, it is what? It is methyl alcohol. Okay, you will take the number of carbons, you will put il, and you will put alcohol after it. And then ethanol, it's ethyl alcohol, very simply. We move on to the next question. Part B. Ethanol is produced from sugar by fermentation. Fermentation is a process that produces a dilute solution of alcohol. How can the process be concentrated, or how can you get pure ethanol? Very simply, you will use fractional distillation. We move on to part C. Write an equation to show how ethanol is produced from ethene. What conditions are needed for the reaction to occur? Ignore state symbols. First of all, you will take ethene, C2H4 plus H2O. It will then produce what? It will produce ethanol, C2H5OH. The conditions needed, we need phosphoric acid at 300 degrees Celsius and 60 to 70 atmosphere. That is part C done. We move on to part D. In part D, they said list 3 common uses of ethanol. 3 common uses of ethanol. It can be used as a fuel. It can be used as perfumes. It can be used as even drugs, like as alcoholic drugs, because alcohol, if you drink it, it is a drug. So that is pretty much it. Now they skipped E and F. They went all the way to G. What is produced when ethanol is warmed with a suitable oxidizing agent? When ethanol is warmed with a suitable oxidizing agent, meaning it's the oxidation of ethanol, we will form what? We will form ethanoic acid. So the oxidization of any alcohol will give you its carboxylic acid. So ethanol, its oxidation will give us ethanoic acid. Let us now look for the next question. Next question we have is CQD number 14. In CQD number 14, they said name and give the molecular and structural formulas of the first 3 organic acid. First 3 organic acid mean it has 1 carbon, 2 carbons, and 3 carbons. The first carbon, which is methanoic acid, okay, it will look like this. It will be 1 carbon bonded to 1 H, and then it has double bonded to O and single bonded to OH. This is how methanoic acid looks like. Then the 2 carbons, which is ethanoic acid, okay, it's going to be carbon 1, carbon 2. This is double bonded to oxygen and single bonded to OH. This over here is bonded to H, bonded to H, bonded to H. So this is ethanoic acid. And if it has 3, then it is propanoic acid. So it's 1, 2, 3 carbons. This is double bonded to O, single bonded to OH, H, H, and then H, H, H. So that is pretty much it for part A. For part B, they said what methods can be used to produce ethanoic acid. To produce ethanoic acid, it can be prepared by the oxidation of an ethanol. So, oxidation of ethanol. And then, another way is the bacterial oxidation during vinegar production. So that is pretty much it for this question. We move on to part C. So for part C, they said write an equation to show how ethanoic acid can be produced in the lab. So how do we produce ethanoic acid in the lab? First of all, let's write the equation. It is C. 2H5OH will react with Cr2O7 2 minus, in addition to 16H plus, without the 16, in addition to H plus, to give us 3C2H4O2, in addition to 4Cr3 plus 11H2O. So I balanced these. Let me also balance these. This will be 16H plus 2 over here and 3 over here. I don't think something like this will come because it's not given in the notes. But if it did come, you should know that it reacts in the presence of dilute sulfuric acid, which is H2SO4. Now, what gas is produced when ethanoic acid reacts with zinc? When ethanoic acid reacts with zinc, it will produce hydrogen gas, always hydrogen gas, H2 gas. And if it will react, okay, if ethanoic acid reacts with PCl5, okay, it will produce Cl2 gas. That's pretty much it. So we finished CQD number 14. We move on to CQD number 15. They told us that ethanoic acid C3COOH can be prepared from ethanol C2H5OH or ethanal, which is C2H4O. Identify the type of such reaction. If it will be prepared from ethanol, it will undergo oxidation. So ethanol will undergo oxidation to form ethanoic acid. So this type of reaction, it is oxidation. Now, which of the following reagents are needed for preparation of ethanoic acid from ethanol or ethanal? So for both of them, you will need acidic dichromate solution and acidic permanganate solution. That's pretty much it for CQD number 15. Let us see, we have then CQD number 16. In CQD number 16, they told us draw the general structure formula of an ester and circle the functional group. Okay, the general structural formula of an ester is this. You can draw it in many ways. How they gave it to us in the answer kit is R single bond C double bond O single bond O R prime. So it looks something like this, or another way you could do it is without the R. You could write C double bond O single bond O, and you can keep it like this. This is the general structural formula of an ester bond. Okay, so part B lists 2 common uses of esters. We use esters in perfumes. Okay, and as artificial flavoring. Artificial flavoring. Now for part C, which ester will be produced if ethanol and methanoic acid react? So, if ethanol and methanoic acid react, let us name this ester together. Okay? So, again, if ethanol will react with methanoic acid, it will produce an ester. To name this ester, what we are going to do is we are going to take the alcohol, the name of the alcohol. It's going to be first. How many carbons are there in the alcohol? We have 2 carbons. So, eth, and then after it we will put il. And then how many carbons do we have in the acid? We have 1 carbon, so it's going to be meth, and then we will add anoate. So, ethyl methanoate, this is the name of the ester. Or, if we wanted to represent it, it would be like this. First of all, it is ethyl methanoate. Okay, so we're gonna take the number of carbons of the carboxylic acid, and it's gonna be the number in the ester bond. So it's gonna be C H O. So double bond O, single bond O, and then because it is ethyl, so we're gonna have 2 carbons, 1, 2. This is gonna be CH2, and this is gonna be CH3. Very simply, this is it. So now we move on to CQD number 17. They told us the following equation represents the reaction between ethanoic acid and propanol. Give the name of this reaction. This is esterification. So now they want us to draw the structural formula for product A. First of all, let us find the name for product A. So this is the alcohol, and this is the acid. So what we're gonna do is we're gonna take how many carbons are there in the alcohol. We have 3, so it's gonna be propyl. And now how many carbons are there in the acid? We have 2, so it's gonna be ethanoate. And if we were to draw it, so we have to put first of all the number, the ethanoic acid, and then we will put the propanol. So then it is gonna be C single bond C H H H double bond O single bond O, and you will forget about the H, and the OH will go also, and now you will have C H H C, C, here is H, here is H, here is H, here is H, and here is also H. And what did we remove? We removed an H over here and an HO over here. So together they will combine to make water. So we finished B and C. Let us move on to part D. In part D, they told us compound B has the same molecular formula of compound A. Okay, so it is propyl ethanoate. So that means in total it will have 5 carbons. So 3 plus 2, that is 5 carbons. Okay, they told us choose the name of the carboxylic acid and alcohol that react together to form compound B. Together, you should add them and they should give you 5 carbons. So meth, which is 1, prop, which is 3, this will give us 4. But, which is 4, eth, which is 2, this will give us 6. Prop, which is 3, eth, which is 2, this will give us 5, so C is an answer. And then eth, which is 2, meth, which is 1, will give us 3. So C is definitely for sure our answer. So now we'll move on to CQD number 18. In CQD number 18, they said petroleum and coke are considered fossil fuels. Are they renewable sources of energy? No, they are not renewable. They are non-renewable sources of energy because they need over millions of years to reform. So just say they need over millions of years, or they need a very long time in order for them to reform. Let us go down to the next question. The next question we have is CQD number 19. So in CQD number 19, list 4 fractions obtained from the fractional distillation of crude oil. State 1 common use of each. First thing, the 4 fractions obtained from fractional distillation of crude oil. We have natural gas or refined gas. Okay, this is used for lighting and heating purposes. Then, after natural gas, we have naphtha. Naphtha, it's like this, okay? It is used to make gasoline, okay? Or plastics, or the thing they use for the roads. I don't know what they call it, the road paving. Okay? After the naphtha, we have kerosene. Okay? The kerosene, it is a fuel for jets, so fuel for jets. And then finally we have diesel oil. Okay, diesel oil, it is used for combustion engines. That's it for CQD number 19. We move on to CQD number 20. They told us distillation normally produces large amounts of long straight chain hydrocarbons which have limited usage. On the other hand, short branch chain hydrocarbons which are in high demands are normally produced in relatively low quantities. What process is used to convert the less useful fractions into more useful fractions? This is a process called cracking. You will crack the long chains into smaller chains, into smaller chains. You get what I mean. Okay, so now we move on to CQD number 21, grid. Give the name of the process used to separate petroleum into components. This is fractional distillation. Okay, which physical property is the base for this process? Okay, whenever they ask you the physical property in the base for the process of fractional distillation, it should be the difference in boiling points. So, difference in boiling points. Okay, what is the most volatile fraction? The most volatile fraction is always the top fraction, and this also means that it has the lowest boiling point. That is pretty much it for CQD number 21. We will move on to the next CQD, which is CQD number 22. In CQD number 22, they said define the following terms. So the first term is polymerization. I will say it then I will write it. Polymerization is the process of joining small and simple molecules called monomers to form a large macromolecule called a polymer. So joining of small monomers to make large polymers. Okay, now define what is a monomer. A monomer is a molecule that's linked to other identical molecules to form a polymer. So linked, actually no, it's a small molecule linked to other identical molecules to form a polymer. Okay, now for part B, name the two classes of polymers. Name the two types of polymerization processes. We have two classes of polymers. They are either natural or they are synthetic, meaning they are processed. Synthetic. Okay, and then two types of polymerization processes. They are condensation and addition. That's pretty much it for CQD number 22. Now we move on to CQD number 26, which is a grid. In this, they are telling us polymers can be either synthetic or natural. What are polymers? How are they formed? Polymers, I'm not gonna write them. You guys can write them if you want. But polymers, they are giant macromolecules. They are formed by the linking, when you link or join a bunch of small repeating units, and these units are called monomers. Monomers are joined either by breaking the double covalent bond between their carbon atoms, this is called addition, or eliminating some atoms, this is called condensation of small molecules as a byproduct. Okay, and that is pretty much it for CQD number 26. Now we move on to CQD number 28. So they said, draw a diagram including structural formulas to show the polarization of ethene. First of all, ethene is the C double bond C, H, 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 and H, okay? And then we have an N over here to show that you have multiple monomers, which is ethene. Now, to make polyethene, you need what? You need heat, you need pressure, this is for the cracking, and you need a catalyst, okay? Sorry for my bad handwriting, I'm writing because in a very difficult position, catalyst. Okay, so now it is gonna look something like this. You're gonna have C single bond C, you will break the double bond open. You will have a bond here, you will have H, 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 this is an H, and H, and you will have N over here. Now, if they asked us, what is the monomer? Identify the monomer. First of all, the monomer, it is this over here, and the repeating unit, it is this one over here. Okay, now they told us name the polymer form, it is polyethene. There are other names for it, you can check them in the answer key. So that's CQD number 28. Let us go down, see, we have also CQD number 23. Okay, write an equation to show how the following compounds polymerize. First of all, take C2H4, C double bond C, H, 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 H. Okay, it is like this, first of all, then the double bond will break, and then it will look something like this. It will be C single bond C, bond here, you will have H, 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 and you will have an N over here. So like that, we finished C2H4. Now it's the same thing for C2F4, so it's like C double bond C, F, 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 and then you have N over here. And then you break the double bond, it will be C single bond C, and then F, 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 and then you will have an N over here. Now finally, C2H3Cl, this is C double bond C, H, 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 and Cl, you will have N over here. So then you break the bond, it will be C single bond C, you will have H over here. It will not write like it's, let me write it somewhere else. C double bond C, you will break the double bond, it will be C single bond C, and then bonds here, then you will have H, 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 and Cl, and then you will draw the brackets like this, and then you will have N over here. So that is pretty much it for part AI. Now they need part A, II. Are the polymers produced by addition or by condensation? They are produced by addition. because we are breaking the double bond so that we can add more elements to our compound. Now write an equation to show how styrene C6H5C double bond CH2 will polymerize. First of all, you will see the double bond where it is. It's over here. So C double bond C. Then over here you have C6H5. Okay. Then you have an H over here, and an H over here, and an H over here. Okay, and then it will have an N over here. So you will break the double bond. And when you break the double bond, it will be C single bond C. You will have over here C6H5, H, H, and H over here. And then you will put an N over here, and that's how it is done for part B. Now we'll move on to the next CQD, which is CQD number 29. So CQD number 29. PET is one of the most used polymers. It's used in packaging foods and beverages. Okay, what are the monomers involved in polymerization of PET? It is the monomers. They are two actually. They are diol and a dicarboxylic acid. Okay, for part B, draw the structure of PET, the polymer. It will look something like this. Okay, it's gonna take up the space, so I'm gonna use it down. We'll have C, double bond O, single bond, a box that is filled. Okay, and each box corresponds to something. And then we have C, double bond O, single bond O, single bond, a plain box. And then we will go back to O, and this is the end of the monomer. Not the monomer, sorry, the polymer, my bad. It will look something like this. Now we will move on to part C. In part C, they said identify the type of the linkage form. So the linkage, as we saw before, it was like this. It was like a C, double bond, O, and then single bond O. This linkage, we call it what we call it, an ester link. Okay? Now it could look like this, or even it could look like this. So C, double bond O, single bond O over here, and then it will continue. So no matter where the O is placed, whatever this is, it will look like an ester link. So this is what? An ester link. Now what is a characteristic of PET polymer? PET polymer can be converted into, so this can be converted into monomers and repolymerized. Okay, so that's it for CQD number 29. Now we will move on to CQD number 27, grid. They said give the main differences between addition and condensation polymerization. In addition, we have that the double bonds are being broken and that all atoms in the monomer can be found in the polymer. Okay, whereas in the condensation polymerization, we have atoms or group of atoms are eliminated. So let's say atoms or group of atoms is eliminated. Okay, and some are lost as the byproduct. So some are lost as byproduct. So that's very simply it for CQD number 27. Let us move on to CQD number 24. What does CQD number 24 say? It says consider the following two monomers, this and whatever that is, represent the structure of the polymer that can be produced when the monomers react together. So very simply, as you can see over here, this is, if you are to write it in a closed format, in the simplest, in the molecular formula, it will be C2H4OH2. And this over here, it will be C6H4COOH2. So this is a little bit complicated. They said represent the structure of the polymer that can be produced when the monomers react together. You can use X and Y to represent certain groups of atoms. So the group we're going to be talking about here is C2H4. We will call it X from now on. And C6H4, we will call it Y from now on. So the structure when they join together, it will look something like this. I don't think it will come, but just like it will be HOCOOY, and then COOOH, in addition to what? In addition to HOXOH, they will react together to form this over here, which is OCOOY COOX and N over here. So it's a bit complicated, but I don't think they will bring anything like this in the exam, hopefully not. Now we will move on to part B. They said, what is oh, I forgot also something before also there is to NH2O, so there is H2O being left as a product. So they told us, is the polymer produced an addition or a condensation? It is a condensation because there is a loss of water, or there is a byproduct which is water. Now they wanted us to circle the ester group in the polymer. Again, our polymer was like this: O, C double bond O, Y, C double bond O, O, X, and then N. They need the ester group, and the ester group is very simply like this. So that is it for CQD number 24. We now move on to CQD number 25. They told us the structure of nylon can be represented as such. Is nylon an addition or a condensation polymer? Very simply, it is a condensation because there is going to be a byproduct, okay? And there is no breaking of double bonds, by the way. If there was breaking of double bonds, then yes, it is an addition. But there's no breaking of double bonds, so it is a condensation polymer. They told us circle the amide bond, okay? Or the peptide linkage in the above structure. It's going to be over here. When they are saying peptide linkage or amide bond, it always has to contain N, carbon, oxygen, hydrogen. So it always contains hydrogen, oxygen, carbon, and nitrogen. Okay, now there are the structure of the monomers from which nylon is produced. Okay, we're gonna take them into two different groups. Okay, so we have this one over here, COOH, single bond CH2, 4, single bond COOH, and the second group, it is NH2CH2, 6, single bond NH2. So that is it for CQD number 25. So let's go down. Now I don't think there's any more CQDs, so that's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.